Hello friends, I myself Dr. Bharat Parab. We are studying today the identities for the positive real numbers. First one, root of a into b is equal to root of a into root of b. Root of a upon b is equal to root of a upon root of b. Another, root a plus root b into root a minus root b as shown here is equal to a minus b. Another identity, a plus root b into a minus root b is equal to a square minus b. We multiply two brackets here, root a plus root b in one bracket and root c plus root d in another bracket. Then a multiplies to c and d, the another bracket. Here we get root ac plus root ad. Again b multiplies to c and d. So we get a root bc plus root bd. And another one is root a plus root b the whole square is equal to a plus 2 root ab plus b. So from identities we move on to the exponents. In a raised to m, a is a base and m is exponent, or it's called as power also. So we get a raised to m into a raised to n is equal to a raised to m plus n, as bases are same, base are the same, then we add the powers or exponents. Another, a raised to m upon a raised to n is equal to a raised to m minus n. A raised to m and whole raised to n is equal to a raised to m into n. So we multiply this. Another one is a raised to m into b raised to m is equal to ab the whole raised to m. That is, if exponents are same or powers are same, we can multiply this to the same power. Okay. Another one is very important, a raised to m upon n. N is in the denominator position, so we take nth root of a the whole raised to m, that is same equal to nth root of a raised to m. Okay, so these are the exponents and the identities. So write this and read every day and get it by heart. The best place is to stick on the backside of the toilet door where you can read every day. If you have any difficulty, let me know in the comment box and I shall try to solve it. Thank you. So we try to solve the problems after having a look at the formulas. So we first see application or uses of different types of properties of real numbers and the rational numbers, how they are used to solve the problem. Okay, now we have associativity property, commutativity property, like that. So we are using it now. Okay, so let us take an example. See here, we're taking 3 upon 7 and plus of minus 5 upon 13 plus 7 upon 26 and plus minus 8 upon 21. So we have to take LCM, as 7 is a factor of 21 and 13 is a factor of 26. So we need not take the LCM of all this. We take only 26 and 21, that is suffice, that will be enough. So we get 234 minus 210. These are very simple calculations. Plus 147 and minus 208. The ultimate answer we get is minus 37 upon 546. Okay, this is the answer. Now you have found out the answer. Okay, now we are trying to solve the same example by using different properties of real numbers and rational numbers, and see, that becomes very simple. That Now this is the same example. If you see, look at the denominator, this is factors, and these can be associated. 3 upon 7 and minus 8 upon 21 can be associated, and minus 5 upon 13 and plus 7 upon 26 also can be associated. So you are using the associativity property, and also we are changing the places and using same time the commutativity property for simplicity. And now you can see the solving this problem becomes very easy. See, this is LCM, not so hectic. So we take first LCM as 21 and another LCM as 26, and these are very simple subtractions, and you get 1 upon 21 and minus 3 upon 26. Now you have to take LCM of 26 and 21, but you are dealing with the smaller numbers comparatively than the previous one. Okay, because your answer gate is minus 37 upon 546. That is same. See, this answer matches with this answer, but in the second stage, or the using the properties makes it very simple. Okay, that is why these properties are made and they are used in this. Okay, so try to solve the problems on this yourself. So we are now trying to find out the rational numbers between two rational numbers. Okay, so there are two methods to find out. Remember, we are finding out rational numbers, not irrational numbers. Rational numbers between two rational numbers. Okay, so we see here the first method, which is a very simple method. Of course, both the methods are very simple. Okay, we see here, we consider the example as 3 upon 10 and 7 upon 10. So we have to find out the rational number between these two numbers. If denominators are not same, make them same by multiplying suitable factor. Okay, so we write 3 upon 10, 4 upon 10, 5 upon 10, 6 upon 10, 7 upon 10 are 4, 5, 6. All these numbers are in between 3 and 7. So these are some numbers, rational numbers between 7 upon 10 and 3 upon 10, between these two numbers. Okay, but 3 upon 10, if you multiply numerator and denominator by 10, can be written as 30 upon 100. That is same, we are not changing any value. And 7 upon 10 can be written as 70 upon 100, like this. So any numbers between these two, that is 30 upon 100, then 31 upon 100, 32 upon 100, 42 upon 100, till 69 or 69 point something. Okay, these are all numbers in between. You can add many numbers if you want. Any number, infinite numbers can be written. Okay, now we go ahead, that like 30 upon 100 can be written as, you multiply again by 10 to numerator and denominator, so it is 300 upon 1000. Get it here? Okay. And 70 upon 100 can be written as 700 upon 1000. These are the same numbers. So we can write any numbers between 300 and 700 divided by 1000. Now this is the first number, then any number 301, 302, any numbers. Okay, you can write as many numbers as you want. This is a very simple method. You have to only multiply numerator and denominator of both the terms by 10 and increase the interval or the limit you have to answer. Okay, now 300 upon 1000 can be written as, you multiply again by 10, 3000 upon 10,000, 3000 upon 10,000, and 700 also can be written as, let us write this first, and 700 upon 1000 can be written as 7000 upon 10,000. Okay, now try to find out the numbers between 3000 and 7000, as many numbers as you want, divided by 10,000, and these all numbers will be rational numbers between 3 upon 10 and 7 upon 10. Remember, we are looking for only rational numbers. There is a different method for getting irrational numbers. We are going to see that again now here after some examples. Okay, so this is one method of solving or rather getting rational numbers between two rational numbers. Okay, so infinite numbers can be found out. So we move on to the another method. Okay, so after finding one method to find out the rational numbers between two rational numbers, first method, then second method is to find the mean of the two given numbers. We see the example here. We take same numbers 3 upon 10 and 7 upon 10. If you take mean of these two numbers, that is going to be in between, somewhere in between these two. This is of course in the middle point, that is 10 upon 10 divided by 2, again so it is 1 upon 2, half. Okay, now this is in between 3 upon 10 and 7 upon 10. Now if you see a mean of half, that is 1 upon 2 and 3 upon 10, will be in between first two numbers, and also the mean of 1 upon 2, the new number, and 7 upon 10 will be in between these two. So you got to take this number and any number from any side and find the mean. You can even find the mean of two numbers which are newly formed. Now here we are going to see the mean of 1 upon 2 and 3 upon 10, that will be 2 upon 5. Okay, then you can go and see the mean of 2 upon 5, the new numbers formed, and 1 upon 2, that is also going to be in between the first two numbers 3 upon 10 and 7 upon 10. Here in the meanwhile we have found out the number between 7 upon 10 and 1 upon 2, that is 3 upon 5, which lies in between 3 upon 10 and 7 upon 10. Like that we go on taking mean of any two numbers formed by the numbers which are newly formed within that, or from this number to the end numbers like 3 upon 10 and 7 upon 10. All numbers are going to be in between these two numbers. So many numbers can be found out, in the infinite numbers can be found out. All these numbers will lie between the first two numbers 3 upon 10 and 7 upon 10. So you got to practice yourself. These are very simple problems. Actually, the moment you practice, problems are not problems. As you face difficulty, these are problems. When you try to solve it, these become simple examples. Okay, likewise every mean value between two numbers, any rational numbers, can be found out. Okay, so this is a method to find out any numbers of rational numbers between given two rational numbers. Remember, we are talking about rational numbers. We are now going to find out the numbers between two irrational numbers. Irrational numbers between two rational numbers. Anyway, okay. The, okay, the method is different, and we will be learning that also. Okay, so try solving problems yourself. That will make your subject easy. So after finding the method to find a rational number between the two rational numbers, we move on to the another aspect of the rational or irrational numbers. Is we are now finding a method to find irrational numbers between two numbers, between any two numbers. Okay, now we take, suppose we have these two numbers, any two numbers, take at random. So see, it is a very simple method. Only you should know what are irrational numbers. Okay, then if you want to know what are irrational numbers, I have explained it in the previous videos. You can go and check it, what are irrational numbers. So convert these numbers into decimal expansion, so that will make your problem easy. Okay, so convert these. Okay, so you get 1 upon 8 as, see here, there is no need to explain. These are very simple conversions, like you get 0 0, 1 upon 8 is 0.125. It is very much necessary to convert it into a decimal expansion form. Okay, because you are trying to find out what are irrational numbers. The concept of irrational number is different from rational numbers. Though it is not difficult, you need to know what are irrational numbers first. Okay, then with these two numbers 0.125 and 0.375, any numbers given can be converted in this form. And now write the two numbers in between these two, which are non-repeating and non-terminating. You can write any numbers. I am writing 2 3 numbers just for instance, that you are not supposed to repeat the values as I am showing it, and not terminating also. So 0.130, 001, now 3001, etc. 4001, anything you write, or 2 or 3. The number should not be repeating again, as we have seen in the rational numbers. Now second number is 0.230, and this number lies between 0.125 and 0.375. So 0.3512, say any number you can write. It should not repeat, block should not be repeated. These are called irrational numbers. Okay, and try different examples. This is Dr. Parab, Dr. Bharat Parab. Okay, so we try to convert the digital form, that is 0.3 bar is 0.3333. You can see here, into P upon Q form. This is a unique method. Learn this, which is very important. So let us take x equal to 3 bar. Okay, so that is x is equal to 0.3333 many times it repeats. Okay, so there is only one digit which repeats. See, it is unique technique. We take 10x. Had there been 2 digits, as you will see in the next problems, you will take 100, and for 3 digits repeating you will take 1000. That makes the problem very simple. So we take 10x equal to 10 into 0.3333 into bracket, that is equal to the 10 inside, that is equal to 3.3333. Now how to write a split up of this? Just try to understand this. It is very simple. So from 3.3333 we subtract x. We need x. So we subtract it and see what is the remaining value. Okay, so we subtract 0.3333, which is remaining value is 3. As you can see, every time use the same technique, that become same makes your problem or very easy. So you can write 10x as 3 plus 0.3333, that means 10x equal to 3 plus this 333x. So we get 3 plus x from the right hand side, and transfer this x from right hand side to left hand side with minus sign. So 10x minus x equal to 3. So we get 9x equal to 3. It's very simple. Only thing is, when you are writing it in the splitter form, you should take care. So x equal to 3 upon 9, that is equal to 1 upon 3, and we have successfully found the P upon Q form of 0.3 bar. Okay. So we find another example how to convert repeating blocks more than one digit to P upon Q form. Here we take 1.23 bar, that is 1.2323, like that many times, or repeats infinite number of times. So we take 2 3, these are, so you see, these are 2 3 are 2 digits. So as in the previous example, 10x will not suffice. X equal to 1.23, that is 1.2323, etc. Okay, as these are 2 digits, we take 100. Remember this, try to solve the problems and you will get through. Okay, so we take, just understand this, 100x, so that it will go ahead of this first block at least. 100 into 1.2323, etc. We take 100 into, solve this as 120. 100 into the quantity in the bracket is 123.2323, etc. Now how to split this? So we take this quantity 123.2323 and subtract x from this. So you get 122. This is how you can find out the quantity in all the examples. Okay, then write this 100x as, that is 123.2323, as 122 plus 1.2323, that is which is x. We have considered 1.2323 as x. Now it is very simple. Now transfer this x from right hand side to left hand side. 100 minus that is 100x minus x equal to 122, that is 99x equal to 122, that is x equal to 122 upon 99. Very simple. Remember how to find out the value in between, that is subtracting x, that's all. So we move on to the another example where the block has 3 digits. Earlier we have seen 0.3, only 3 repeats, and 1.23, 3 repeats, 2 digits. Now here 3 digits are repeating, 001. So we take x equal to 0.001, take this value as 1, which is actually equal to 0.001001 infinite number of times. So remember, there are 3 digits. This is unique technique, and remember this, you will not find any problem if you remember this small technique, where if there are 3 digits, then in the earlier case which you have found out 10x, then 100x, there this should be 1000x, then only you can get the value very easily, that is 1000x equal to Now x value is 0.001001. Write at least two times so that you will not get confused. And then take into bracket 001 and 1.001, 1.001, like that. 001 continues. Now we have to write this so that you get x. So subtract this quantity 1.001001, subtract x from this quantity. Okay. So you can find out how to write it in a addition or subtraction manner. Okay. So we take 1.001001 and subtract x, that is we subtract 1 point. Okay, got it. So we get 1.00000. Okay, got it. It is very simple. So that is how we get 1000x is equal to 1 plus x, that is 0.001, repeating. Okay, so we get 1 plus x, that is x. So we transfer this from right hand side to left hand side. 1000x minus x equals 1. So it is 999x equal to 1. So x you get as 1 upon 999. This is in the P upon Q form, and we have successfully found out. Remember this technique and try to solve the problems. This is Dr. Parab for you. So we see here the terminating decimal expansion. What does that mean? For P upon Q to have terminating decimal expansion or a remainder of a division to be 0. That means if a division is carried out, the remainder is 0. That means the quotient will be terminating. That we call as terminating decimal expansion. Okay. What are the conditions? Conditions are we must have denominator q, if factorized, contains only 2, 4, 8, 16, 20, 32, etc. That is 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to n as powers of 2 as factors, or 5, 25, 125, that is 5 raised to 1, 5 raised to 2, 5 raised to 3, 5 cube, or 5 raised to n as factors, or both 2 n-th powers or exponents and 5 n-th powers or exponents as factors. But it strictly should not contain factors, should not contain any other number other than 2 or 5. Okay. In other words, we say denominator q becomes 10 or power of 10, like 10 raised to 1, 10 square, 10 cube, etc., 10 raised to n, either by multiplying or dividing by 2 or 5 several times, 2 and 5 several times, but no other number is involved. If this condition passes, then we will have terminating decimal expansion. Okay, so this, in mathematical language, we say for P upon Q to have terminating decimal expansion as explained above, or a remainder of the division to be 0, is possible if denominator q has prime factor of 2 or its powers like 2, 4, 8, 16, 32, that is 2 raised to 2, 2 raised to 3, 2 raised to 4, like that, 2 raised to n, etc., or prime factors of 5 and its powers like 5, 25, 125, that is 5 raised to 1, 5 raised to 2, 5 raised to 3, etc., or both 2 and 5 only, but no other number is involved. Okay, so this is a terminating decimal expansion explanation. So we try to solve a very tricky problem, that is we have to prove that minus of minus x is equal to 0. Like that, if you take this sign inside, minus 1 into minus 1 is plus 1. We are not supposed to prove like that here. We are supposed to prove the other way, that is the additive inverse way, that is x plus minus x equal to 0. So x is a additive inverse of minus x, and minus x has a additive inverse of, that is x. Okay, so we write here. Are you getting it? This is very tricky statement. Try to understand it, think over it, you will definitely get it. It's not difficult. Only thing is minus x plus x, like that some language is used. So we get minus x plus x is equal to 0. So x is a additive inverse of minus x. Okay, and by the definition of additive inverse, we have a number which is having a negative sign. So negative sign to minus x, we write it like this. We negative sign to minus x is additive inverse, but negative sign, but additive inverse of minus x is x. That means we have proved that minus x minus of minus x is equal to 0. Okay, just read it. If you have any difficulty, write me in the comment box. I shall definitely try to solve this. This is Dr. Bharat Parab for you. Okay. So we see this another method of simplifying the examples. Method is called as rationalizing the denominator. Remember this. Okay. So we take the example 1 upon 2 plus root 5. So we use the identity a plus root b into a minus root b is equal to a square minus b. Remember this identity, get it by heart, and we multiply the numerator and denominator by the same quantity which doesn't change the value, 2 minus root 5 and 2 minus root 5. So we get 2 minus root 5 in the numerator and 2 square minus root 5 square in the denominator. So that solves again. 2 minus root 5 is 4 minus 5 and you get minus 1. Take the sign inside and you get minus 2 plus root 5, that is root 5 minus 2. This we have simplified the problem by rationalizing the denominator. This method, remember this method, try to solve the problems. Though it is very simple, you need to solve as many problems as you can. Okay. So here we try to solve some problems. I have covered two identities. See here that you are supposed to solve infinite number of problems to get yourself practice. Now this is a problem 2 raised to 2 upon 3 into 2 raised to 1 upon 3 is what? Okay, this is a simple identity that we use this formula. A raised to m into a raised to n is equal to a raised to m plus n. While by adding this formula, write and by heart, okay, and use them in the examples, you will remember it properly. You will not forget it till the till you get retired from your job, till more than it is 60. Okay. So see this 2 raised to 2 upon 3 into 2 raised to 1 upon 3 is equal to 2 raised to the add the exponents of the powers. You get that you get 2 raised to, as you see, 3 upon 3, that is 2. Okay, this is one example. It's very simple, but still you need to practice many examples, and very simple because you practice, or it's not simple. Okay, just by looking at the example or the formula, you cannot use it. Okay, here we use another example, another formula, 5 raised to 1 upon 5 raised to 4. Remember this, I have covered all this in the previous section, that is a raised to m whole raised to n is equal to and you multiply this a raised to m into n. Similarly, you have to use this. That is 5 raised to, you have to multiply here. 5 raised to 1.5 into 4 is 5 raised to 4.5. That is how to solve it. So, though they are simple, try to solve the problems. Okay, get practice, and that will make you master of this. Okay, this is Dr. Bharat Parab for you. Okay, if you have any difficulty, write me in the comment box, and I shall definitely try to solve your difficulties. Okay, now solving as many as examples to get uh, maths subject very easy. Okay, write and by heart the formulas. Don't just read and by heart. Okay, these are the techniques given by me.